to another video. Today we'll be doing the concept of the mole. Now, first of all, what is the mole? Mole is just a quantity used to represent unit amount of a substance. So for example, we know that one dozen of a substance equals 12. One score equals 20. A gross equals 144. So a mole is just like these. Well, the number for a mole is 6.023 times 10 to the 23. And so a mole of anything, a mole of eggs, a mole of computers, a mole of anything contains 6.023 times 10 to the 23 of those. So let's look at how moles relates to particles like atoms. Now, in the 18th century, chemist Amadeo Avogadro did some research and found that a certain mass of each chemical compound always contained 6.023 times 10 to the 23 particles, or 1 mole of particles, and this just happened to be within the relative atomic mass or the relative molecular mass of the substance. So let's take, for example, aluminium. The relative atomic mass of aluminium is 27, and because of how the unit of mole is set, it's 27 grams of aluminium that contain 1 mole. So 27 grams of aluminium contains 6 times 0.23 times 10 to 23 particles. Same way, the atomic mass of carbon is 12, and 12 grams of carbon is the amount that contains 1 mole. Now this right here, this is known as the molar mass. So the molar mass is the mass in grams of 1 mole of a chemical substance. Now what if we were to find relative molar mass of a compound? Let's say we had sulfuric acid H2SO4. We would go ahead and find the relative atomic masses of all the different elements. So we'd have hydrogen, which is 1 times 2. We would have plus sulfur, that's 32. Oxygen is 16, and we're multiplying that times 4. And by punching all of that into a calculator, we would get 98. So we know that this right here is 98 for its relative molecular mass, and we just change this to grams per mole, and so right then and there we know that the molar mass for sulfuric acid is 98 grams per mole. Alright, so now we've talked about how mole relate to mass. Let's see how it relates to volume. See, the good thing about the mole as a concept is that the mole for gases, for ideal gases, the mole allows us to connect mass with volume. Mass and volume are two very different quantities, so you cannot really just convert between them. But the mole concept allows us to do that when we are dealing with ideal gases. So let's just take a look at that. Now, the molar volume is the volume occupied by 1 mole of a gas. And the molar volume depends on the temperature and the pressure. So we're going to deal with two specific temperatures and pressures, which are RTP, stands for room temperature and pressure, and this is equal to 101 101.3 kilopascals or 1 atmosphere, and the volume is 24 dm cube. And then we have STP, standard temperature and pressure. It's the same 101.3 kilopascals, except now it's 22.4 dm cubes. So let's say we had about 88 grams of carbon dioxide gas at RTP. We can now find out what volume this 88 grams would contain by looking at the mole and how it relates to volume. So firstly, we'd have to calculate the molar mass of carbon dioxide. And of course, we know that carbon has a relative atomic mass of 12, and plus oxygen is 16. So multiply 16 times 2. So that's 32 plus 12, which is 44. So the molar mass of carbon dioxide is 44 grams per mole. And so if 44 grams is in 1 mole, that will make 88 grams, 2 moles. So we have now 2 moles of carbon dioxide at RTP, and we know from the mole relation to volume that at RTP there's 24 dm cube in 1 mole. So we know that this 88 grams would contain 48 dm cube in terms of volume. And then that right there is how you would use the mole concept to relate the concepts of volume with mass as it relates to ideal gases. That's all for this video. Thank you for watching. I'll continue the mole concept in another video. Thank you.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.